Thanks everybody for coming. It's great to be here. This is my first CSV conference, and it is my first time giving this talk and presenting this part of our vision. I don't do a lot of conferences, but I thought you all would be the perfect audience to hear this message. So thanks for coming in here and sitting and listening to what I have to say. Folks over in the corner, we've got a few empty seats over here if you like. We live in a world of data models, and especially relational data models. They power the tools that we use to get our work done every day, and they structure the data sets that we want to analyze. Today, to create a data model, you need two things. You need technical expertise in data modeling itself, and of course you need domain knowledge of the domain being modeled. Usually these things are not in the same person. So the solution that we have today is usually you take somebody who already has technical expertise in data modeling, and then you have them go out and gather the domain knowledge through interviews. What we usually don't do is start with somebody who already knows the domain and just teach them how to model data. If it's always easier to start with knowledge of data modeling than knowledge of any other domain, the implication seems to be that data modeling is the hardest thing in the world to learn. And the result is that there's a whole ton of domain knowledge out there just waiting to be unlocked. It's locked up in people's heads. There are millions of interesting and useful data models that could help millions of people in their life, their work, their research, if only they were able to create them. Now, it wasn't supposed to be this way. In the book Go To, the author Steve Lohr tells the story of the creation of SQL at IBM in the 1970s. The creators of SQL wanted to create a language that could be understood easily by ordinary humans and make it possible for them to interact with data. But ultimately, they concluded they'd been too optimistic. After some of the early usability studies, this was their conclusion in the 70s. So 40 plus years later, how do we bring about this vision? How do we bring about a world where end users are not just passive consumers of models created by software experts, but are active participants in the process, building useful data models for themselves? If you've ever been frustrated with a tool, be it Trello or GitHub or anything else you used maybe to track your work or do your research, if you've ever been frustrated with something that that doesn't fit your workflow, your process, or exactly what you want to track, you felt the pain of a mismatched data model. And you felt the need for this world where you can create exactly the model that you want and work with it easily. Well, to bring about this world, I think we need to look at our tools, look at who they're designed for, and what they're optimized for. The traditional SQL database is designed by and for developers. It's an infrastructure component, right? And it's optimized for performance and scaling. Now, this is all well and good. We need databases like this. But what would a database look like if it were designed for end users and optimized for usability and learnability? Well, it would look something like this. So this is Fieldbook. It is a database that looks and feels like a spreadsheet, but supports relational data, querying, and it has a REST API. So just for a quick demo to give you the feel of it, this is a little demo with some public company data. You can scroll through it, select and edit text just like in a spreadsheet. But it's super easy to do queries. So say I want to do a filter for companies with a market cap of greater than 100 million, sort by their earnings, and group by their country. Boom. So just like that, I've done a filter, sort, and group type of query. And now I can scroll through these results. And I mentioned also it handles relational data. So this country column here is not just text. It's actually a link to a country sheet. The countries have been normalized out into their own sheet. You see them here. And it supports formulas that use this relational model. So like if I want to figure out the total market cap of companies, I could just say sum of companies dot market cap, and now you've got that formula, that calculation there. So this is how easy it can be to work with data in something like Fieldbook. The thing about the SQL model is that because it's optimized for the machine, rather than for the user, it puts a good amount of cognitive load on the user. A simple example of this, just to sort of tell you what I mean by cognitive load, is the fact that SQL databases are statically typed. So when you create to even get started working with the database, you've got to do a bunch of upfront configuration. You have to create a schema, a data model. And to do this, you have to know what tables you're going to have, what columns you're going to have, what types those columns are, which ones are nullable or not. If you want to add another column into a table, you got to know what type it's going to be, and so forth. Very helpful for the machine to optimize for performance, but it adds cognitive load on the user. So if you're optimizing for the user, you want to make that a lot easier, right? You want to say if you want to add a column, it's just a click of a button. And you don't have to say what type it is. So in Fieldbook, like in spreadsheets, you can enter numbers, or you can enter text as well, and they can coexist in the same column. So it's more like dynamically typed rather than static. OK, that's just a simple example of what I mean by optimizing for the user instead of the human. But that's a really easy case. Let's talk about some stuff that's trickier. How do we handle relational modeling? This is a really key thing that the spreadsheet model doesn't do very well, but that end users definitely want to do. In the SQL model, this is done through foreign keys. So typically in a SQL database, every record will have a numeric ID, that is its sort of unique global reference. If you want to say we want to track some people and what cities they live in. Well, we would have two tables, people and cities, and then you'd add a city ID column to the people table. This is called a foreign key column, and this would contain the ID of cities. So London is identified by ID 2, and when we have Alice has city ID 2, that means she lives in London. Okay. Not too hard to understand, but clearly optimized, again, for the machine, not for the user. When you glance at this cities column, you don't want to see a bunch of numbers, right? You really want to know what cities are these people in. So the simple way that we make relational modeling more accessible to users is to say we're going to base it on names. So here I'm going to take that cities column and denorm it normalize it into its own sheet, cities sheet. And now when we want to add a new city to somebody, we can just do it based on the name. I can even start typing, and now we're creating links based on names instead of IDs. Okay. So again, pretty straightforward, but we're starting to evolve the model towards something that's optimized for the end user. This model of having a column that references another table gives us a one-to-many relationship, right? A belongs to relationship in data modeling terms. We say that each person belongs to a city, like Alice belongs to London. Anytime you have a belongs to relationship in a data model, you've got an implicit relationship in the opposite direction too, called a has many relationship. A city has many people. In this case, both Alice and Dave are in London. But in the traditional SQL model, the has many relationship is implicit. You can't see it just by looking at the cities table. You have to know that it's sort of implicitly there. And if you want to see which people are in a city, you have to do a query. And you have to know what query to do, right? It's something like this. Select star from people where city ID is 2. That's how you see all the people who are in London. To know how to do this query, you have to not only know SQL, you have to also know the structure of the table. You have to know that this people table has a city ID. And again, you can't tell that just by looking at the cities table. So one thing that helps end users, we've found through our usability testing, is to just make this explicit. Here in a similar example, if I go into my cities now and I click into London, we can actually see a form view. And because of that link back to the people table, we automatically essentially run that query for you and show you the explicit reverse relationship. OK. Still pretty simple. Let's take things up a level. Very often people want to do not just one-to-many, but actually many-to-many relationships. This is another thing that came out very clearly in our user testing. Suppose, for instance, we wanted to track not just where does the person live now, but say all the cities they've ever lived in. Well, then we would need a many-to-many relationship between people and cities. And in a SQL database, it looks something like this. You can't do this directly with just two tables in SQL because a foreign key column only supports one value. Again, this is optimizing for performance, so the database can organize data in a very compact way. It's great for the database, but it's not so great for people because you now have to have this third table an intermediate table called a join table. This is highly non-intuitive, right? If you haven't been trained, if you haven't taken a SQL class, if you haven't been trained in this kind of thing, you'd have to be pretty smart and like come up with some invention to figure out, maybe I could do this with a third table. You know, it's not, and this third table has no, it doesn't correspond to anything in the user's mental model, right? It's an implementation detail. It's an implementation detail that kind of sticks out like a sore thumb, right? It doesn't correspond to any concept in the mental model. It's more about the physical model of the database. And we've gotten one more level implicit, because now notice that this relationship between people and cities is now not obvious from looking at the people table or the cities table. It's only clear when you discover that there's this intermediate table here. So again, if we want to optimize for the user instead of the machine, what do we do? Well, a simple way to do this is just to allow multiple links in a cell. This is harder to implement, and it's harder to optimize for performance, but it's much easier for people to understand. So in Fieldbook, we do this. We allow you to have not just one, but multiple links in a cell, and you can assign people to multiple cities. And now we see both Carol and Alice are in London. If we click on that, we'll see all of them here. So in user testing, this worked pretty well, except there was one thing that people would get confused about when they were setting things up. Should I start from the people table and link it to cities, or should I start from the cities table and link it to people? Users who hadn't been trained in data modeling got confused about this, and they would often get it wrong. They would get it backwards, and when they got it backwards, they were confused and frustrated. It wasn't really what they wanted. So after dozens of these tests and seeing a lot of people upset, we eventually moved to a model that we call bidirectional or symmetric relationships. So now in Fieldbook, whether you start from the people table and link to cities, or start from cities and link to people, you end up with the same result. So it's impossible to get it wrong. It's a good principle of making things user-friendly. If there's a choice the user doesn't have to make, eliminate it. That way they can't make it wrong. So, so going back to the first example, when I linked these two, I linked this city column to the cities table, and a people column was automatically created. These two columns are the dual of each other, and they're automatically kept in sync. So if I add Alice to New York here, and then I go back to the people table, New York has been added to Alice. And so both sides of the link are kept in sync automatically as you edit them. Essentially what we've done is there's an implicit join table, right? That third table, that intermediate table, it's behind the scenes, and it's being managed for you. All right. So now we've solved relational modeling, right? There's a catch. I slipped something by you in the beginning. I glossed over the hardest part of the problem. The first thing I said was that instead of making links based on numeric IDs, we're going to make them based on names. Where do names come from? How do you name a record? This turns out to be like a deep ontological question, right? It turns out to actually require a lot of domain knowledge to choose the right name for something. And this is not at all something that comes naturally to people, like understanding what this choice is and how to configure this correctly. It's tough. So it turns out naming things is hard. This is a classic quip, a saying that goes around in computer circles. It's two hard things in computer science, and naming things is one of them. It's very true. So one of the things that makes it hard is that name isn't even always the right term. So people and organizations have names, cities and countries maybe, but books and movies, it's really a title. You call it the title, not the name. Sometimes there isn't a single column that is the right name or identifier or descriptor for something. So if you're talking about types of cars, you might have make, model, and year, right? Or there could be a similar thing for wine. Or sometimes sometimes you've got people, but you just want to split out first name and last name. Some things don't have any natural attribute that serves to identify them, and so we make up artificial attributes, IDs, right? So if you place an order with a retailer, you'll probably get a numeric order ID for that, just as a handle to refer to it. And other things don't even have explicit IDs that we think or talk about. So if you had multiple line items in that order, each one would be its own entity in a database, but you don't talk about a line item ID. It's a hidden thing that the end user doesn't really even generally need to know. So just communicating the concept to end users is difficult. Getting them to select the right thing is difficult. We went through a lot of failed attempts. So in an early version of Fieldbook, you could select any column to be the quote-unquote name column. And we had this option in the menu here. And so in a people table, you could go to the age column and say, use this as the name column. And people had no idea what that meant, so they would just pick it to see what it did. And then it didn't do anything that was obvious, so then they would just leave it that way. And then they would go to some other sheet, and people would suddenly be numbers, and they would just give up at that point, right? We thought maybe it would be more obvious if instead of choosing a column, maybe if you were configuring the title on a detail page. So maybe for a task, you could choose one of the fields to be like the title. And we tried to make it, anyway, this was also confusing. People didn't know what to do with this. We had another version where sheets started off with no name column, just IDs. And then this was a total disaster because people would make a link and then they would try to start auto-completing to fill in the link, and they would just get a list of IDs, like person 1, 2, 3, 4, and they would just be like, what is this? I give up. So we even designed this super complicated configuration dialog at one point that we had this plan. It was going to pop up when you made a link and force you to configure the name column before the link was. We came to our senses before we implemented this. And what finally worked more or less is to just say, hey, look, the first column is just the name always, right? Whatever you put in the first column, it's like a special column, and we're just going to use that for the record identifier. This people pretty much get. There's just one problem, which is it doesn't actually match all those scenarios that I talked about earlier, right? It works well for names and titles that just are in a single field. It doesn't work really well when you've got like multiple columns you want to combine. It doesn't work well when you want to sort of create an artificial ID or something, or when things don't have names at all. So the new model that we're moving towards and beta testing now is that you can actually have multiple name fields. So let me pop out and demo this. So here is a version of the thing that we're working on. So in this example, you've got people, but you have both first name and last name. And so you've got this sort of line that you can drag around to say, okay, how many columns am I going to use, basically, for name? And so in this case, it's 2 of them. And again, this is linked to cities. When I go to the cities table, you'll see that it's using both the first and last name to create the ID. Cities just have one name, so the line is just right here. And then say we wanted to track people visiting cities on different dates and so forth. That doesn't really need a name. I don't know, what would you call this, right? So instead, we just drag the line all the way over to the left, and we have 0 name columns. And if you absolutely need to refer to a visit, it'll get a numeric ID. So this is something we're just implementing and beta testing, but I'm optimistic about this. In our early dog fooding, it feels really like the right model. So, to sum up, the traditional SQL model gives you statically typed columns, relationships based on a foreign key model that give you, therefore, one-to-many or belongs-to type relationships, where the inverse relationship, the has-many, is implicit, and the whole thing is based typically on numeric IDs. Taking a more user-centered approach leads you to a model with dynamically typed columns, links instead of keys or IDs, many-to-many relationships by default, that explicitly bidirectional thing where you can see both sides of every relationship, and the whole thing based on record quote-unquote names, which themselves are based on 0 or more columns. Taking this user-centric approach as our compass, as our North Star, I believe there are many technical tasks we can make much more accessible to end users. Not just data modeling, but sophisticated imports and exports, transformations, aggregations, reports, and ultimately even coding itself. And that's how we bring about a world of builders. Thank you.